For the first few problems in the Chapter 7 review sheet, we want to use substitution to help us solve the system of equations. For number 1, it looks like the x would be the easiest variable to isolate. So we can move the y to the other side and then subtract the 6. So we have y equals x minus 6. And now we can replace the y in the second equation with x minus 6. So we have 3x plus 5x minus 30 equals 2. So 8x equals 32. So x equals 4. And now to find y, we just need to plug the x in. So y would equal negative 2. So our solution is 4, negative 2. And we always want to write our solution as a coordinate. In number 2, it looks like that the second equation would be the easiest to isolate x. So we just need to add the y to the other side. So we have x equals y. And now we can plug in the y for the x above. So we have y plus y equals 2. So 2y equals 2. So y equals 1. And since x equals y, we know that x will equal 1. So our solution is 1, 1. In number 3, it looks like it would be easiest to isolate x. So if we add the y over, we get x equals y plus 3. And now we are going to replace the x with y plus 3. And it looks like we'll be solving for y first. So we have 4y plus 12 minus y squared equals 7. And to solve this one, we're going to need to factor. So we'll get everything on one side. So I'll add the y squared over and subtract the 4y and subtract the 12. So I have positive y squared minus 4y minus 5 equals 0. And if we factor that, we will get y minus 5, y plus 1. So we'll get two solutions for y equals 5 and y equals negative 1. So this solution set will have two solutions. So now I'll plug in 5 to the equation for x to find out that when y equals, there we go, that's a 3. So to find that when y equals 5, x will equal 8. So I have a solution at 8, 5. And then I'll plug the negative 1 in. So when y equals negative 1, x will equal 2. So I have a solution at 2, negative 1. In number 4, we're given that y equals x minus 1 and y equals x minus 1 cubed. So since we have y equals for both equations, I'm just going to plug the x minus 1 in for the first y, and that will just take the two equations and set them equal to each other. So then I'm going to expand the right side and get x cubed minus 3x squared plus 3x minus 1. And then I'll move the x over and add the 1. So we get 0 equals x cubed minus 3x squared plus 2x. And it looks like I can factor out an x. So I'll get x squared minus 3x plus 2. And factoring further, I'll get x minus 2x minus 1. So for this problem, I have three solutions. One at x equals 0, x equals 2, and x equals 1. And then to find y, I just need to plug it in, and I can use the first equation. So if I plug in 0, I'll get a negative 1 for y. So I'll have a solution at 0, -1. And if I plug in 2, I'll get a 1 for y. So I'll have a solution at 2, 1. And if I plug in 1, I'll get a 0 for y. So I'll have a solution at 1, 0. For number 5, we have x squared plus y squared equals 169, and 3x plus 2y equals 39. So I am going to I'm going to isolate the x here. So I have 3x equals -2y plus 39. And then I'm going to divide by 3. So I have x equals -2/3 y plus 13. And I will take that and plug it in for x. So I have -2/3 y plus 13 quantity squared plus y squared equals 169. So if I FOIL out -2/3 y plus 13, I'm going to get 4/9 y squared. And then -2/3 times 13 would be -26/3. And if you double that, we'll get -52/3. And then 13 squared is 169 plus y squared equals 169. So luckily the 169s will cancel, and I'll just pretend that this is a 9/9. So I can add it to the other y squared. So I'll get 13/9 y squared minus 52/3 y equals 0. And it looks like we can factor out a 1/3 y, and that will give us 13/3 y minus 52. So it looks like we will have a solution at y equals 0 and 13/3 y minus 52 equals 0. So 13/3 y will equal 52. We multiply by 3/13. Hopefully that comes out to be a nice number. Does 13 goes into 52 4 times, so we end up with y equals 12. So now we still need to find our x values, so we can just plug 0 in for y, and we'll get that x equals 13 when y equals 0, so we'll have a solution at 0, 13. Then we'll plug in 12. And let's see, -2/3 times 12 would be -8. -8 plus 13 would equal 5. So when we plug in 12 for y, we get 5, 12. Oh, and I messed up on the first one. Need to switch my x's and my y's. So be careful on that. If you solve for y first, make sure we put 12 in for y. Oh, oops, that's the second one. So let's see, we want to put in 0 for y and 5 in for, or 13 in for x. There we go. For number 6, we have y equals 2x squared and y equals x to the 4th minus 2x squared. So again, since these are both set equal to y, we can just set them equal to each other. So we have 2x squared equals x to the 4th minus 2x squared. So I'll just subtract the 2x squared to the other side and get x to the 4th minus 4x squared. And that will give me an x squared to factor out. Get x squared minus 4. And then I'll get x plus 2, x minus 2. So x equals 0, x equals negative 2, and x equals 2. So we're going to have 3 solutions for this system of equations. So to find what the y values are, we simply just need to take the x values and plug them in to either equation. Probably the easiest equation would be y equals 2x squared. So if we plugged in a 0, we would get y equals 0. If we plugged in a negative 2, we would get negative 2 squared, which is 4, and 4 times 2 is 8. And if we plugged in a positive 2, we would also get an 8. So our solutions are 0, 0, negative 2, 8, and positive 2, 8. For our next 3 problems, we're going to be solving the system of equations using elimination. So it looks like that in this case, y would be the easiest variable to eliminate. So I'm just going to multiply the top equation by 8. And that will give me 16x minus 8y equals 16. And adding those 2 equations together would give me 22x equals 55. And dividing by 22, I would get that x equals 5 halves. So now that I know x equals 5 halves, I can plug that in and find y. So I'm just going to plug it back into the first equation. So 2 times 5 halves minus y equals 2. So 5 minus y equals 2. So 5 minus 2 would equal y. So y equals 3. So the solution is 5 halves, comma 3. In problem number 8, we have a system of equations with a bunch of fractions. So it would be easiest to first multiply by the common denominator to eliminate the fractions and then go from there. So I'm going to multiply the top equation by 50 each term. And that would give me 10x plus 15y equals 7. And the bottom equation I'm going to multiply by a negative 5 just so I get some negative answers and some positive answers. So that gives me a negative 2x. Oh, I should multiply by a 10. I'm sorry. Let's rewrite that. A negative 10. Okay, so that will give me a negative 4x minus 5y equals negative 2. So now I can work with this other system of equations, which has kind of easier numbers. So it looks like it would probably be easiest to eliminate the y's. So I'm going to multiply the bottom equation by 3. So that will give me a negative 12x minus 15y equals negative 6. And then I'll rewrite the top equation. So that will give us a negative 2x equals 1. So x will equal negative 1/2. And then I just need to plug that in to find y. And I am going to plug that into this equation. So negative 4 times negative 1/2 minus 5y equals negative 2. So that would be a positive 2 minus 5y equals negative 2. So negative 5y would equal a negative 4. So y equals a positive 4/5. So my final answer would be negative 1/2 and positive 4/5. In number 9, we have an equation with decimals. So I am going to multiply that by 10. So we can get rid of all the decimals. That will give me 15x plus 25y equals 85. And now for elimination, I am going to multiply the top equation by, looks like if I multiply it by 1.5, I can get a 25y. That might be a little bit difficult to do. So I'm going to multiply the top equation by 5 and the bottom equation by 2. And that will help me eliminate the y's. So let's multiply this by a negative 5 and the bottom equation by a positive 2. So that will give me negative 30x minus 50y equals negative 220. And the bottom equation will be 30x plus 50y equals 170. And since both the x's and the y's cancel out, we get 0 equals negative 50. And in this case, we have an inconsistent system. Or we could say no solution. Either answer is fine. For numbers 10 and 11, we have a system of 3 equations with 3 variables. So the goal is to first eliminate a variable twice. So we have just 2 equations with 2 variables. So it looks like it would be fairly easy to eliminate the z's. So I'm going to add the second and third equation together. So the z's will cancel out. So that will give me 2x plus 3y equals 13. And now, since I eliminated z the first time, I have to eliminate z again. So I am going to multiply the second equation by 3, which will give me 6x minus 3z equals a negative 12. And combining those equations together will give me 7x minus 2y equals negative 17. So it looks like maybe the next easiest equation to easiest variable to eliminate would be the y's. So I'm going to multiply the first equation by a negative 2 and the second equation by a 3. So that will give me negative 4x minus 6y equals negative 26 and 21x. Ooh, we should have multiplied it by a positive 2 up top because it's already negative. So let's change these guys to positives. There we go. We'll change him back to a positive. So 21x minus 6y equals a negative 51. So that will give me 25x equals a negative 25. So x will equal negative 1. So now to find another variable, we could take the negative 1 and plug it back in. So I'm going to plug it back into 2x plus 3y equals 13. So 2 times negative 1 plus 3y equals 13. So negative 2 plus 3y equals 13. So 3y equals 15. So y will equal 5. And then we just need to take both equations and plug them back in to find z. So we have actually we can just plug in x for the second equation, and that will help us find z easily. So we have negative 2 minus z equals negative 4. So negative z equals negative 2. So z equals 2. And then we just want to write the final answer as a coordinate. So negative 1, comma 5, comma 2. In our next problem, we want to take a look at all three variables and decide out of all three which one is easiest to eliminate. So it either looks like x or z would be the easiest to eliminate, and I am going to choose z. So I'm going to add the first two equations together to get 6x minus 5y equals 20. And since I haven't used the top equation yet, I have to use it. So I'm going to multiply that by 3 to get 6x plus 9y plus 3z equals 30. And I'm going to combine that with the second equation to get 8x plus 6y equals 52. So unfortunately I didn't get very easy numbers to work with, so I am just going to multiply the first equation by a 6 and the second equation by a 5. So that will give me 36x minus 30y equals 120, and 40x plus 30y equals 260. So then that will give me 76x equals 380, and hopefully 76 goes in nicely to 380. And it does. X equals 5. So now I'm going to take that and plug that back in. So I'll plug it back into the 6x minus 5y equals 20 equation. So 6 times 5 minus 5y equals 20. So 30 minus 5y equals 20. So negative 5y equals negative 10. So y will equal positive 2. And now I'm going to plug that all back into the first equation. So 2 times 5 plus 3 times 2 plus z equals 10. So 10 plus 6 plus z equals 10. So z will equal a negative 6. So my final answer is 5, 2, negative 6. The next two system of equations, I already told you that they have an infinitely many solutions, so we need to create a point generator. So first thing we need to do is eliminate a variable. And looking at all three of these, it looks like it would be easiest to eliminate an x. So I'm going to multiply the first equation by a negative 1. So I get negative 5x minus 5y plus z equals 0. And I'm going to combine that with the bottom equation. So I get 10y minus 8z equals 0. So that gives me that negative 8z equals negative 10y. So z equals 5/3 y. Or I'm sorry, 5/4 y. So now this might be different than the answer that you came up with, depending on which variable you isolated. So now I'm going to let y equal a. So z equals 5/4 a. And now I'm going to plug those two back in to see what x equals in terms of a. So I have 5x plus 5a minus 5/4 a equals 0. And to get rid of the fractions, I'm just going to multiply through by a 4. So 20x plus 20a minus 5a equals 0. So 20x plus 15a equals 0. So 20x equals negative 15a. So x will equal negative 3/4 a. So my point generator is negative 3/4 a, comma 5/4 a. So now if you let x equal a, you would have gotten a slightly different answer, and that would have been a, negative 4/3 a, and negative 5/3 a. So depending on what you let a equal, you will get a different answer. But it is still correct. In number 13, I am going to eliminate the y's. So I'm going to add the first and third equations together to get 4x plus 8z equals 6. And it looks like it would be easiest to isolate the x. So I have 4x equals negative 8z plus 6. So x equals negative 2z plus 3/2. And I'm going to let z equal a. So then x equals negative 2a plus 3/2. And now I'm going to take those and plug it in. So I want to get y in terms of a. So I'm going to plug the x in to the second equation. So I have negative 2a plus 3/2 plus 2y equals 5. So negative 4a plus 3 plus 2y equals 5. So 2y equals 4a plus 2. So y equals 2a plus 1. So my point is negative 2a plus 3/2, comma 2a plus 1, comma a. For 14 and 15, we have two systems of equations, and they have three variables with two equations. So in this particular situation, we are always going to have infinitely many solutions because we have two planes, and the only way they can intersect is in a line. So we need to automatically create a point generator. So to create a point generator, we first need to eliminate a variable. So if I look at 14, it looks like x would be the easiest variable to eliminate. So I am going to multiply the first equation by a negative 3 and the bottom equation by a 5 to eliminate the x. So that'll give me negative 15x plus 36y minus 21z equals negative 48. And the bottom equation, I'll get a positive 15x minus 21y plus 20z equals 45. So that will leave us with a 15y minus z equals negative 3. So in this case, z is definitely the easiest variable to isolate. So I am going to subtract the 15y and then divide by negative 1. So z equals 15y plus 3. So now I'm going to let y equal a. So z equals 15a plus 3. So now we just need to plug in the a and the 15a plus 3 for y and z and solve the equation in terms of x. So it looks like maybe the second equation would be the easiest to plug everything into. So I have 3x minus 7a plus 4 times 15a plus 3 equals 9. So 3x minus 7a plus 60a plus 12 equals 9. So 3x plus 53a equals a negative 3. So 3x equals negative 53a minus 3, and dividing by 3 gives us x equals negative 53 thirds a minus 1. So even though that's a little ugly, that looks like that's what it comes out to be. So our point generator is negative 53 thirds a minus 1, a, and 15a plus 3. For number 15, we also need to create a point generator. So I am going to eliminate the x's, since that looks like it's the easiest to eliminate. So I'm going to multiply the top equation by a negative 3 and the bottom equation by a 2. So I'll get negative 6x minus 15y plus 57z equals negative 102, and 6x plus 16y minus 62z equals 108. So adding these together, we will get y minus 5z equals 6. So y equals 5z plus 6. We're going to let z equal a. So y equals 5a plus 6. And now we just need to take both of these and plug them in. So we have 2x plus 5 times 5a plus 6 minus 19a equals 34. So 2x plus 25a plus 30 minus 19a equals 34. So we have 2x plus 6a equals 4. So 2x equals negative 6a plus 4. So x equals negative 3a plus 2. So our final answer, negative 3a plus 2, 5a plus 6a. For this next problem, we want to graph the two curves and find out their points of intersection. So we can see that the first curve is a parabola since it's squared. And to find out its x-intercepts, I can just factor it. So I know that I have an x-intercept at 0 and an x-intercept at 6. And then I know that the vertex will have to lie on x equals 3 since that is in the middle. So if I plug a 3 in, I'll get a 3 squared, which is 9, minus 18, which is negative 9. So my vertex is down at negative 9. So my parabola look like that. So now I want to graph the line 2x minus y. So if I subtract the 12 and add the y, I'll have y equals 2x minus 12. So put the y-intercept down at negative 12. And now I go up 2 over 1 until we have our line. And I know it'll intersect the x-axis at x equals 6. So it looks like my 2 points of intersection, I know I didn't draw this graph very beautiful, but it looks like my 2 points of intersection are at 2, negative 8, and at 6, comma 0. And I could always plug those in and double check to make sure that they work for both problems. And if you plug a 6 into the first equation, you would get a 0 for y, so we know that works. If you plug a 6 and a 0 into the second equation, you would get 12. And if we plugged a 2 in, 2 squared minus, which is 4, minus 12 is negative 8. So it looks like it works for the first one, and it would definitely work for the second. So those look like my 2 points of intersection. For number 17, we want to graph the inequality. So we can tell that number 17 is a circle with a vertex at 1, 4. And it has, a center at 1, 4. And has a radius of 3, so we want to go out 3 in all directions. And to connect our circle, we want to use a dashed line since it's strictly greater than. And for shading, since it is greater than 9, greater than the radius, we want to shade on the outside of our circle. For number 18, we have x plus y is less than or equal to 1. In order to graph this equation, if we cover up the y value, we have an x-intercept at 1. And if we cover up the x, we have a y-intercept at 1. So we know that our line will connect these 2 points, and it will be a solid line since it is less than or equal to. And to figure out where to shade this line, we could plug in the point 0, 0. If we plug in the point 0 plus 0, it holds true to the equation. So we would shade where that point is, which is down below. For the next problem, negative x plus y is less than or equal to 1. If we cover up the y, we have an x-intercept at negative 1. And if we cover up the x, we have a y-intercept at positive 1. And it is also a solid line. And if we plugged in the point 0, 0, it would also hold true for this equation. So it would be shaded below the line where 0, 0 is located. Our final equation is, or inequality, is y is greater than or equal to 0. So that's just the horizontal line at 0. So we would shade above. So the solution set would be located in the region where all the shadings combine, which would be right in this triangle area. For number 19, and in the first equation, if we cover up the y's, we'll have an x-intercept at -2. If we cover up the x, we'll have a y-intercept at 3. And this will be a dotted line, since it is strictly less than. And again, we can plug in the point 0, 0, and 0 plus 0 is less than 6. So that holds true. So we would want to shade below. For the next problem, we have x minus 4y is greater than -2. So if I cover up the y, I'll have an x-intercept at -2. And if I cover up the x, I'll have a y-intercept at +1/2. So we have a less steep line. And if we plug in the point 0, 0, it would also work, since 0 minus 0 is greater than -2. So we would want to shade where that is located, which is also down below. Our next equation, 2x plus y, is less than 3. If I cover up the x, I have a y-intercept at 3. And if I cover up the y, I have an x-intercept at 3/2. And if I plug in the point 0, 0, again, it would hold true. So I would shade below the line where 0, 0 is located. So it looks like my solution set would be located in this region where all the colors combine. In number 20, we have 3x plus 2y is less than 6. So if I cover up the y, I have an x-intercept at 2. If I cover up the x, I have a y-intercept at 3. And this would be a dotted line. And I would want to shade below, since 0, 0 would be a point that would work in the equation. Then I have the inequality, x is greater than 0, so that would be a dotted line on x equals 0, and I would want to shade to the right. And finally, I have the line y is greater than 0, so that would be the dotted line on the x-axis, and I'd want to shade above. So it looks like that this solution set is located in this little triangular area. 21, 22, and 23 are all partial fraction decomposition. So what we want to do first is factor the denominator. So we have x plus 2 and x plus 4. And now we want to separate the fraction by saying a over x plus 2 plus b over x plus 4. And now if we were to add these two fractions together to get back to the original, we would need common denominators. So we would have to multiply the a by x plus 4. And we'd have to multiply the b by x plus 2. And once we did that, we should get back to our numerator, which is 4 minus x. So now we want to solve for a and b in order to get our partial fractions. So to solve for a, I'm going to let x equal -2. So I'm going to plug a -2 in wherever I see an x. And the reason we let x equal -2 is so we can multiply b by 0 and have it cancel out. So I'll end up with 2a plus 0b equals 6. So a will equal 3. So I already know the first part of my answer. I know that my first fraction is 3 over x plus 2. Now I'm going to let x equal negative 4 and plug that in wherever I see an x. And what this will do is cancel out my a. Ran out of room. So I will get negative 2b equals 8. So b will equal negative 4. So the second part of my answer will be negative 4 over x plus 4. So these two fractions are my final answer. For number 22, we have a term in the denominator that's squared. So whenever this happens, we need to write the factors, and the denominator is already factored. We need to write 1x minus 3 to the first power, and then an x minus 3 squared. Since the common denominator of all three of these terms would be x times x minus 3 squared. So we have to account for the x minus 3 that's to the first power. So now if I were to add all these fractions together and get a common denominator, I would need to multiply the a by an x minus 3 squared, since he already has an x. I would need to multiply the b by an x and then only one x minus 3 to get to an x minus 3 squared term. And then I need to just multiply the c by an x, since he already has an x minus 3 squared. And that will equal my numerator, 27 minus 7x. So now I'm going to let x equal 0, and that will cancel out the c and the the c and the b, since it has an x there, and if I plug in 0, it'll just zero out. So I'll get a times a negative 3 squared equals 27 minus 7 times negative 3. 7 times 0. Plug in 0 for x. So I'll get a 9a equals 27. So a will equal 3. Now I'm going to let x equal 3 in order to cancel out the a term, since that'll become 0, and the b term to help me find the c term. So I'll get 3c equals 27 minus 7 times 3. So 3c will equal 27 minus 21, which is 6. So c will equal 2. So now that I've found a and c, I need to find b. But there's nothing else I can plug in to cancel out any more terms, because I've already plugged in 0 and I've already plugged in 3. 3. So now I'm going to let x equal an easy number, like 4, since 4 minus 3 is 1. And I'm going to plug that in wherever I see an x. So I'll get a times 4 minus 3 squared plus b times 4 minus 3 plus 4c equals 27 minus 7 times 4. So that will just be 1a plus 4b plus 4c equals 27 minus 28, so negative 1. And now that I know that a equals 3 and that c equals 2, I can plug those in. So I will get 11 plus 4b equals negative 1. So 4b will equal negative 12. So b will equal a negative 3. So now I've solved for A, B, and C, and I can finally write my final answer, which will be 3 over x minus 3 over x minus 3 plus 2 over x minus 3 quantity squared. The last problem also has a squared term in it. So we need to write two terms, a over x minus 1 to the first plus b over x minus 1 squared. So for a, I'll only need to multiply him by an x minus 1 to get to an x minus 1 squared. And luckily for b, I don't need to multiply him by anything since he already has the common denominator. And that will equal 5x minus 2. So in order to solve for b, I'm going to let x equal 1. So that will cancel out my a terms. So I just get that b equals 3. And again, I've already plugged in all the numbers I can to cancel out other terms. So I'm just going to let x equal an easy number, like 2. So I get a times 2 minus 1 plus b equals 5 times 2 minus 2. So a plus b will equal 10 minus 2, which is 8. And I already know that b equals 3. So a plus 3 equals 8. So a must equal 5. So now my final answer is 5 over x minus 1 plus 3 over x minus 1 quantity squared.